So the first question is, a financial services company regularly runs an analysis of the day's transaction costs, execution reporting, and market performance. The company currently uses third-party commercial software for provisioning, managing, monitoring, and scaling the computing jobs, which utilize a large fleet of EC2 instances. The company is seeking to reduce costs and utilize AWS services. Which AWS service could be used in place of the third-party software? You have got 4 options for this. This is your option 1, this is your option 2, this is your option 3, and this is your option 4. You have got 10 seconds time to answer the question, and your time starts now. Time up. Now let us analyze the answers. This is option 2, Amazon Athena. This option is incorrect because Amazon Athena is a query service that analyzes data stored in Amazon S3. While it is great for data analysis, it's not designed for managing and scaling computing jobs. So option number 2 is the wrong answer. Option 3, AWS Systems Manager. This option is also incorrect because AWS Systems Manager provides a centralized way to manage your AWS resources, but it's not designed for running batch computing workloads. So option number 3 is also the wrong answer. Option 4, Amazon Lex, is incorrect. Amazon Lex is a service for building conversational interfaces such as chatbots. It's not related to managing computing jobs. Okay, so option number 4 is also the wrong answer. Option 1, AWS Batch, is correct because AWS Batch is a service that enables you to run batch computing workloads in the cloud. It eliminates the need for provisioning, managing, and scaling computing resources. AWS Batch can handle large-scale computing jobs, making it a great fit for the company's needs. Okay, so at the end, your AWS Batch, that is option number 1, is the correct answer. Okay, let us move to the next question. A financial services firm has traditionally operated with an on-premise data center and would like to create a disaster recovery strategy leveraging the AWS cloud. As a solutions architect, would you like to ensure that a scaled down version of a fully functional environment is always running in the AWS cloud, and in case of a disaster, the recovery time is kept to a minimum. Which disaster recovery strategy is that? You have got 4 options for this. Option 1 is this one, this is option 2, this is option 3, this is option 4. You have again got 10 seconds time to answer the question, and your time starts now. Alright, time up. Now let us analyze the answers. Option 1, Pilot Light, is incorrect because Pilot Light is a disaster recovery strategy that involves keeping a minimal version of the environment running in the cloud. This approach is cost effective but requires more time to scale up in case of a disaster. And option number 2, Backup and Restore, is also incorrect because Backup and Restore is a disaster recovery strategy that involves backing up data and restoring it in case of a disaster. This approach is not suitable for this scenario as it doesn't involve keeping a scaled down version of the environment running. Right, so option number 2 is also the wrong answer. Okay, option number 3, multi-site, is also incorrect because multi-site is a disaster recovery strategy that involves having multiple identical environments running in different locations. This approach is more expensive and complex than what's described in the scenario, right? So option number 3 is also a wrong answer. Option 4, warm standby, is correct. Why? Because warm standby is a disaster recovery strategy that involves keeping a scaled down, fully functional version of the environment running in the cloud. This approach ensures minimal recovery time in case of a disaster, making it the best fit for this scenario. Right? So at the end, option number 4, warm standby, is the correct answer. Okay, let us move to the next question. A company has a production VPC and a pre-production VPC. The production VPC uses VPNs through a customer gateway to connect to a single device in an on-premises data center. The pre-production VPC uses a virtual private gateway attached to two AWS Direct Connect connections. Both VPCs are connected using a single VPC peering connection. How can a solutions architect improve this architecture to remove any single point of failure? So this was your question. You have got 4 options. This is option 1, this is option 2, this is option 3, and this is option 4. And you have got 10 seconds time to answer the question. Your time starts now. Time up. Now let us analyze the answers. Option 2, add a second virtual private gateway and attach it to the production VPC. This option is incorrect because adding a second virtual private gateway and attaching it to the production VPC wouldn't remove the single point of failure, as the VPN connections are the bottleneck. So option number 2 is also the wrong answer. Option number 2 is the wrong answer. And option 3, add an additional VPC peering connection between the two VPCs. This option is also incorrect because adding an additional VPC peering connection between the two VPCs wouldn't remove the single point of failure, as the VPC peering connection is not the bottleneck. Right? So option number 3 is also the wrong answer. Option 4, add a set of VPNs between the production and the pre-production VPCs. This option is also incorrect because adding a set of VPNs between the production and the pre-production VPCs wouldn't remove the single point of failure, as the VPN connections between the production VPC and the on-premises data center are the bottleneck. Right? So option number 4 is also the wrong answer, discarded. Option 1, add additional VPNs to the production VPC from a second customer gateway device. This option is correct. Why? Adding additional VPNs to the production VPC from a second customer gateway device would remove the single point of failure. If one VPN connection or customer gateway device fails, the other can take over. Right? This is why option number 1 is more reliable and is the correct answer. Got it? Let us move to the next question. A company is migrating an application that comprises a web tier and a MySQL database into the AWS cloud. The web tier will run on EC2 instances and the database tier will run on the Amazon RDS for MySQL DB instance. Customers access the application via the internet using dynamic IP addresses. How should the solutions architect configure the security groups to enable connectivity to the application? So you have got 4 options for this question. This is your option 1, this is your option 2, this is your option 3, and this is your option 4. So you can see it's a bit difficult to navigate through the options, right? So this is why if you want some more time than 10 seconds, you can take your time by pausing the video, but as we are following the standard timer, I have to give you the 10 seconds timer itself, and the timer starts now. Time up. Now let us analyze the answers. Option 2, configure the security group for the web tier to allow inbound traffic on port 443 from 0.0.0.0 by 0. Configure the security group for the DB tier to allow inbound traffic on port 3306 from 0.0.0.0.0 by 0. This option is incorrect because the DB tier security group allows inbound traffic on port 3306 from anywhere, which is a security risk. So we don't want that. Option 2 is the wrong answer, discarded. Option 3, configure the security group for the web tier to allow inbound traffic on port 443 from the IP addresses of the customers. Configure the security group for the DB tier to allow inbound traffic on port 3306 from the IP addresses of the customers. This option is also incorrect because customers have dynamic IP addresses. So it's not possible to configure the security group to allow the traffic only from their IP addresses. The DB tier security group should only allow traffic from the web tier, not directly from the customers, right? So option number 3 is also the wrong answer, discarded. Option 4, configure the security group for the web tier to allow inbound traffic on port 443 from the IP addresses of the customers. Configure the security group for the DB tier to allow inbound traffic on port 3306 from the web tier security group. This option is also incorrect. Why? Because customers have dynamic IP addresses, so it's not possible to configure the security group to allow traffic only from their IP addresses. The DB tier security group should not only allow traffic from the web tier security group, not directly from the customers, right? So option number 4 is the wrong answer. Okay. Option 1, configure the security group for the web tier to allow inbound traffic on port 443 from 0.0.0.0 by 0. Okay, having a little bit difficulty to pronounce that. Configure the security group for the DB tier to allow inbound traffic on port 3306 from the web tier security group. Okay, this option is correct because the web tier security group allows inbound traffic on port 443 HTTPS from anywhere, this 0.0.0 thing, which is necessary for the customers to access the application. The DB tier security group allows inbound traffic on port 3306, which is MySQL, only from the web tier security group, which ensures that only the web tier can access the database, right? This is why option number 1 is the correct answer. Got it? Let us move to the next question. A critical web application that runs on a fleet of Amazon EC2 Linux instances has experienced issues due to the failing of EC2 instances. The operations team has investigated and determined that insufficient swap space is a likely cause. The operations team requires a method of monitoring the swap space on the EC2 instances. What should a solutions architect recommend? You have again got 4 options. Yes, this is option 1, this is option 2, this is option 3, and lastly this is option 4. So it's just because of one option that it's a bit difficult to navigate. So again the same thing, once more time, pause the video. Let us start the timer of 10 seconds. Here you go. Time up. Now let us analyze the answers. Option 1, use EC2 metadata to collect information, then publish it to Amazon CloudWatch custom metrics. Monitor swap usage metrics in CloudWatch. This option is incorrect because using EC2 metadata to collect information and publishing it to CloudWatch custom metrics would require custom scripting and is not a straightforward solution, right? So option number 1 is the wrong answer. Option 3, enable detailed monitoring in the EC2 console. Create an Amazon CloudWatch swap utilization custom metric and monitor the metric in CloudWatch. This option is also incorrect because enabling detailed monitoring in the EC2 console provides more frequent metric data, but it doesn't include swap utilization metrics. Creating a custom metric would require custom scripting as well, right? So option number 3 is the wrong answer. Option 4, create a custom metric in Amazon CloudWatch that monitors swap usage. Monitor swap usage metrics in CloudWatch. Okay, this option is also incorrect because creating a custom metric in CloudWatch would require custom scripting to collect swap usage data and publish it to a CloudWatch, right? So option number 4 is the wrong answer. Option 2, install and configure the unified CloudWatch agent on the EC2 instances, monitor swap utilization metrics in CloudWatch. Okay, this option is correct because installing and configuring the unified CloudWatch agent on the EC2 instances is the recommended approach. The agent collects metrics including swap utilization and sends them to CloudWatch. This solution is easy to implement and provides detailed monitoring, right? So option number 2 is the correct answer for this question. Got it? That's it for today's video. I'll meet you in the next video with a new set of questions. Till then, keep learning, keep practicing, and keep exploring. Thank you and bye-bye.